So y-intercept for any graph, not just for a parabola, but for any graph, it's just where your graph crosses the y-axis. And for any graph, you can find that when the x value is 0. If you are on the y-axis of a graph, your x-coordinate has got to be 0. So if you have standard form, if you guys remember doing this a couple days ago, all you do is just literally, I'm going to plug in 0 for x. So if you have standard form, you can actually kind of see the y-intercept. You don't really have to do this work. I'm going to do it on this question so you guys can see. Everywhere you see an x, you would just replace it with a 0. And if you're working with the quadratic and standard form, it wipes out those first two lovely terms because you're multiplying by 0. So if x is 0, y is just 13. Now, if you can tell me y is 13, that's totally fine. I'm going to write down, it actually corresponds to the point on the graph 0, 13, because we're plugging in 0 for x. So it is an actual point if we had a picture of this graph. So y-intercept from standard form is usually pretty quick. You can just see it. It should just be in our ax squared plus bx plus c. It's just the c value. So the number on the end. Now, if you're in vertex form, that's not the case, okay? So I'm just going to have you guys review real quick, just looking at the vertex form. Can you tell me what the vertex is? And then we're going to go through how you would find the y-intercept if you have that form instead of standard form. So if I give you y equals, I got x plus 5 squared in parentheses plus 3. Can anybody tell me what the vertex for that parabola would be? If it's in vertex form, you can see it from the equation. And I would say opposite copy to you to help you. Negative 5, 3. All right, opposite, inside with the x, copy whatever, outside, that's the y. So negative 5, you don't have to write it twice. I don't know why I just did. Negative 5, 3. Okay, now, if we need to find the y-intercept, you can't just see that in the vertex form. But for any problem, if you want the y-intercept, you're just going to set x equal to 0. Here it's just going to look a little bit different than the problem I did above. So wherever I see an x in the vertex form here, I'm just going to replace it with 0. So it's just a little bit different in terms of the algebra steps that you would do. If you do standard form, it just knocks out the first two terms. If you have vertex form, it doesn't really knock anything out. So I would actually go ahead and say, okay, 0 plus 5, right? That would actually just be 5. And we're going to square that and add 3. So 5 squared is going to give you, feel free to use your calculator, 25. Add 3. The y-intercept here would be 25 plus 3, which is 28. So the actual point, I plugged in 0 for x, so 0 would be the x-coordinate. But the y-coordinate would be 28. So it's the same concept. You plug in 0 for x. It just looks a little bit different if you have the vertex form versus the standard form. Okay, so I got another one. This one has a number in front of the parentheses. So negative 2 and then x minus 3 squared plus 6. Can anybody tell me the vertex for that one? The negative 2 doesn't affect it. What would the vertex be? What'd you say? 3, 6. Perfect. All right. Positive 3, positive 6. Exactly right. Opposite looks like a negative 3, so it's actually positive 3, whatever's with the x. And then whatever's outside the parentheses, just copy that down. Okay, now y-intercept here is just going to be like one extra step. I'm still going to set x equal to 0. So I'm going to write y equals negative 2, and then in the parentheses I have 0 minus 3 squared plus 6. Now, if you guys have a calculator with you and you want to type this into the calculator, you definitely you could type that whole thing right in and be done. I'm just going to show you real quick. If I do 0 minus 3, that would just be negative 3 left in that parentheses that we're going to square plus 6. Use your calculator if you want to. I'm just doing this by hand real quick. In order of operations, don't multiply the negative 2 and the negative 3. You would have to square the negative 3 first. So this would be negative 2 times positive 9 plus 6. This would give you negative 18 plus 6, which is going to give you negative 12. Now, I'm just going to grab, and you can use any calculator, it doesn't have to be graphing. I'm just going to show you. If I just took that very first thing I wrote down, I had negative 2, and then in parentheses I had 0 minus 3. That was squared, and then plus 6. You could just type it in. You don't have to sit there and show a bunch of steps. I'm just trying to show you where it comes from. You're more than welcome to use the calculator, though. Now, that would correspond to the actual point. We plugged in 0, and then negative 12. That was our y-intercept. Is anybody having a question? You could do this first one on the calculator too. You just have to remember, plug in 0 for x, and then use your calculator, do it by hand, whatever's easier for you. That'll be your y-intercept. So, both of these guys, y-intercept here, y-intercept here. Okay. Now, what we're going to do here says, given the vertex and a point on the parabola, write the equation of the parabola in vertex form. So you can do this if you have 2 points. Otherwise, you need 3 to write the equation of a quadratic. We're going to talk about that in a couple of days. But if you have 2 points and one of them is the vertex, you can write it in vertex form. So if they give you the vertex and then another point on the graph, it's super important that you label them. Okay, so the vertex is the h and k in that formula. So whatever, and you cannot mix these up. If it says this is the vertex, the x has to go in for the h, the y coordinate has to go in for k. And then the point, for this example, which is 3, 9, you're going to put those points in place of the actual x and y. What we won't know in the equation is the a value. All right, so let me set this up real quick. So I'm going to have the y-coordinate of the point. I'm just using this formula right here. The y-coordinate of the point is going to go in for y, so I'm going to write 9. You will not know the a value. That's the only variable I'm not going to fill in. In parentheses, I have the x, so that has to come from the point. That's 3 minus the x-coordinate of the vertex. That's the h. That's the 5. So it will look like 3 minus 5 there. Don't forget to square that. That's part of what makes it a quadratic, is that little squared there. And then whatever the k value is goes after the parentheses. So for this one, I'm going to put plus 7. If that was a negative number, we would just use the minus. Now, all we got to do is go through, and we're just going to simplify this. So in the little parentheses here, 3 minus 5, that would be negative 2. That's what we're going to square. So I'm just simplifying that a little bit. Does anybody know what I get when I square negative 2? 4, right? Okay, so the term here, this becomes 4. I'm going to write it like this. I'm going to write 4a. I'm just going to put the number in front of it. Plus 7. And we're really just solving this little equation for a here. So I'm going to subtract the 7. 9 minus 7 would give us 2 equals 4a. And I'm just going to divide both sides by 4 real quick. What is my a value? Don't say 2. 1 over 2. People mess that up all the time. So 2/4 is the same thing as 1/2. Now, to actually write the equation, we're just going to have the h and the k, and then we'll have a filled in. In the actual equation, x and y should be variables. So it's going to look similar to this, just where I have the 9, I'm going to put a y, where I have the 3, I'm going to put an x, and where I have the a, we're going to put in the 1/2 that we just solved for. So it would look like this, y equals 1/2, and then x minus 5 squared plus 7. You have the vertex from the directions, and then you have to go through and use that information with the other point to help you find the a value. Once you have that, you're good. Is anybody having a question? Okay, I'm just going to try this with you guys one more. This is very important. Whatever they tell you for h and k, that has, or for the vertex, that has to go in for h and k. Whatever they tell you for the point has to go in for x and y. Just using that formula that's right above here. All right, so we're just going to sub in. So, bless you. In place of the y, I'm going to write 40. Bless you. You do not know the a value, which would help with, like, if we're our pattern, if we had to graph this. So that's what we would not know if we have these 2 points. In for x, the x coordinate of the point, this one's a little weird, but it's 0. Okay, now it's minus the x-coordinate of the vertex. If you want to skip this step, go right ahead, but it'd be like minus a -4, and then the y-coordinate of the vertex would go outside. That's why I keep telling you guys it's the opposite of what it looks like. So if I do minus a negative, that's really 0 plus 4. So whatever that vertex x-coordinate is, that goes in for h. It's going to be the opposite of what it looks like. So to me it looks like a -4. It actually turns out to be a +4 in the equation if you simplify that a little bit. Okay, now let me just do this. In the lovely little parentheses, I'm just going to get 4. 0 plus 4 is 4. And then I'm going to square that 4. So I have 40 equals, 4 squared give me 16. 4 times 4 is 16. I'm going to put the a after that. So all I'm doing to simplify that term, I'm just squaring 4. And we're going to solve this for a. So I have 40, and that's equal to 16a minus 8. So we're going to add 8. 2. This will give you 48 equals 16a. This is a nice number. And the a value, anybody know what it is? 3. Okay, once you have that, I needed that for both pieces. Once you have the a value, to actually write the equation, you just need the h, the k, and the a. We want x and y to be variables in the actual formula. So here, I'm going to write y equals 3 now goes in place of a since we figured that out. And then in parentheses, it's going to be x plus 4 squared and then minus the 8. So you put the h and k in when you actually do the formula. I need the point that they give me in the directions to help me figure out what that a value is supposed to be in front of the parentheses. Is anybody having a question? It's not bad to do. You just have to make sure you don't mix up the vertex and the point. Okay. Now, I'm going to have you look at this, but instead of me telling you like this is the vertex, this is a point, I'm going to give you a picture of the graph. And forgive, I should have typed, I'm going to write this just on my paper. I'm going to have us write this in vertex form here on the back. Okay. Now, the basic difference between the question on the front and this question is you have to get the point yourself. So we need the vertex for sure. So there's my vertex, which looks like 3, 4. And then what I'm looking for is any nice point that goes through a corner. It does not matter what point you choose. I don't have a lot of options on this particular graph. I think there's 2 other nice points. So you have right here, we have 2, 0, and then we have 4, 0. Those are the only other 2 points that look like they go right through the corner of one of those grid marks. So there's only 2 options here, but you got to pick one of the points. Okay, you have to use the vertex. So the vertex here was the 3, 4, and that's going to be my h and k. All right, I tell you what, I'm going to pick the point. It doesn't matter, but either pick the 2, 0 or the 4, 0. It doesn't matter. And we can plug that in for x and y. And then it's literally the same question we did in the front. It's just that you have to pick a set of points off the graph. You have to have the vertex and then 2 options on this graph that you can pick for a point. I just picked the 2, 0, but you could do the 4, 0. We'll get the same answer. It'll just look a little different as we go through here. Okay, so in for y, I'm going to put 0. I don't know the a, and we're going to talk about that in a second after I do this. The x-coordinate of the point is 2 minus the x-coordinate of the vertex, which is h, so that would be minus 3. That's squared, don't forget the squared, plus the y-coordinate of the vertex, that's k, so that's going to be 4. Does anybody know, from looking at the graph, what the a value is without doing the algebra? Just any idea? And if you don't, that's fine. We'll do the algebra. Can you look at the graph and tell me what the a value is? Like what the pattern would be? Not 1, 3, 5, right? Because I'm not going over 1, down 1. So it's not 1, 3, 5. Anybody have any idea what the a value would be? Do what? Oh, I thought you were guessing. You're so close. It's actually -4, and I'll go through and show. Whatever this step is, if I go over 1, okay, I don't get into another nice point until I get down here, right? I go over 1, and I go down 4. So -4 is going to be my A value. If you don't know that, that's okay. I'll show you. We'll just do the algebra just like we did on the front. I would subtract 4 here real quick. So I'm going to get -4 equals A, and then in that parentheses times -1 squared. So I get -4. -1 squared actually becomes +1. So that would be 1A, divide by 1. -4 is my A value. So this would just be y equals -4 times x minus 3 squared plus 4. You need the h and k, but sometimes if you do have a picture of the graph, you might be able to figure out what the A value is before you actually do that algebra. And if you can do that, I have some graphs on the next page of this to practice just to see if you guys can figure it out. But if you can't figure it out, you can always fall back on the algebra. You just need the vertex and a point. So this one's super tricky. This A value is not going to be easy. Let me go ahead. I got to get the vertex. So we're at 2, -1. That's going to be our h and k. And I'm looking for another nice point that goes through a corner. And this one's really hard to determine the A value from the graph, I think. If it's real wide, it means that the A value is going to be a fraction between 0 and 1. I think you have a couple options here that I see that go through nice points, but it's just really 2 on this graph. I have the point 5, 2, and my other option would be the point -1, 2. You just need to pick one of the 2 points. You don't have to use both, but you do have to use the vertex. So for this problem, I would say we have to use the vertex. So that's that 2, -1. That's your h and k. If it's me, I don't know. It doesn't matter. You just pick one of those points. I'm going to do 5, 2. That's your x and y. I'm just picking that because I'm not trying to mess around with the negative if I don't have to. So once you pick those off the graph, and you could use the -1, 2 if you wanted to do that, we would get the same answer. Again, let me write the formula so you guys can see it right here, what I'm going to plug in. So in for y, we're going to put 2. I don't know A. The entire purpose of this is to find A, which is the relationship for the pattern here, which is going to be a fraction because I can see how wide that graph is. All right, x-coordinate of the point is 5 minus the x-coordinate of the vertex, which is 2, and that'll be squared. And then on the end is just the y-coordinate of the vertex. That's -1. So when I plug that in, that'll look like a -1. And I'm just going to kind of do 2 steps in one. I'm going to add 1 to the other side here. So 2 plus 1 is 3. And in the parentheses, 5 minus 2 is also 3, actually. And that'll be squared. So just move the 1, and then I simplified the parentheses. Now, I'm going to go ahead, let's square the 3. So this would be 9 times your A. You're going to divide by 9. And the A value is then 1/3. All right, now all I got to do to write the equation, I need the A, we got that, and we need h and k. So y equals A, which is 1/3, x, and then minus the x-coordinate of the vertex, so it's -2 squared, and then plus k. In this case, k is -1, so it would be -1. That one's kind of a tricky to determine from the graph. Now, the last part just asks if we can convert between standard form and vertex form. So it says convert the equation from example 3 part A to standard form. So let me just rewrite it here. So for that question, we had y equals -4 times x minus 3 squared plus 4. Now, we did this like the very first day of this unit, but I'm going to have you guys practice it again because I think this can be really tricky. And there was something similar to this on the quiz we took yesterday. So what you got to do not distribute the exponent here, but we're going to get rid of these parentheses. So if you're squaring something, right, I'm squaring this. What that means is I'm multiplying it by itself. So you got to write it twice. And then you can FOIL, you can box, whatever you want to do. But my recommendation is to go ahead and take that set of two little sets of parentheses, multiply that together, and then we'll distribute a -4 here in a second. All right, so if I just do like a little FOIL, we're going to just multiply like a double distributive property. So x times x give you x squared. Then you get minus 3x. Then I'm going to turn around and get another minus 3x. -3 times -3 turns into a +9. I'm just going to keep parentheses around that only because I had a -4 out in front of the parentheses originally, so I'm going to have to distribute that. All right, totally up to you. Let me combine like terms here real quick though. -3 would be -6x plus 9. I do need to do a little distributive property here. So everybody in the parentheses is going to get multiplied by -4, and it's really important. Do the FOIL first. Don't distribute first. You got to do in your properties of, or your order of operations, you got to do exponents before you do multiplication. So that's why I needed to do that x minus 3 squared first, and then go through and multiply by the -4. All right, so I got -4x squared. -4 times -6 is going to turn into +24x. -4 times 9 is -36. And then I had this 4 on the outside. So last step there, this would be -4x squared plus 24x. I can put the -36 and the 4 together. That's going to be -32. There's my standard form. I'm just not going to write it again. And don't be tempted to go, oh, those are all divisible by 4 and like divide by. Don't do that. Standard form means we don't have any parentheses. We're not factoring anything. And then if I wanted to do a y-intercept on that one, it should just be if I plug in x is 0 for any graph's y-intercept. If I did that here, it's going to wipe out this term and this term, and I should just be left with that plain number, which is -32. If you want to go ahead and write it out, you can, or if you want to just go, hey, I know I'm going to plug in 0, it's going to get rid of those first two terms, and I'm going to be left with the -32, that is completely fine. Is anybody having a question? Okay, let me have you look at the, I know I just have a bunch of graphs on this last page. I was just going to see if you have a graph, like, could you determine the A value without doing that algebra that we were doing? And sometimes it might be easy, sometimes it might be a little bit tricky, but I'm just trying to save you some time. So let me show you this real quick. Like if I look at this graph, right? Here's my vertex. I'm going over 1, up 1, over 1, up 3, over 1, up 5. So I can just tell right now that's a 1, 3, 5 pattern, right? What is my A value in that situation? If it's just 1, 3, 5. Just 1. Yeah. So maybe you can look at the graph and not have to do that algebra. You'd still need to pick out the vertex, but you might be able to avoid that step where I was trying to find the algebra. Like if I look here, here's my vertex. Like figure what you're doing. I'm going over 1, down 1, over 1, down 3, over 1, down 5. So this would be like -1, -3, -5. If that's my pattern, what's my A value? -1. If it flips upside down, you know it has to be negative. If it goes right side up, you have to be positive. Let me see this one. Okay, so here's my vertex. I go over 1, and then the next nice point is down 2. If you go here, I'm going over 1. The next nice point is actually on that left side, the origin, down 6. So this would be -2, -6. Anybody know what the A value should be there? -2, exactly right. Okay, now this is the one that gets kind of tricky. If it's wider, that means the A value is going to be some kind of a fraction. But if you want to try to figure it out, you might be able to. This guy, between two nice points, right? I'm going not over 1, I'm going over 2, and I'm going up 2. Does anybody have any idea what the fraction would, what do you think? it's 1/2. This is 1/2. If these two are the same, and you can do what I did in the notes too. You can just go ahead and plug the points in. But if it's like over 2 up 2, the a value is going to be 1/2. If it was like over 3 up 3, then it would be 1/3. Let me look at this one. Oops. Okay. So without doing all that algebra, this guy over 1 up 3. Whatever that, if you go over 1 and then up, whatever that first step is, that will be your a value. If that helps you in any way. Otherwise, you can do the algebra. This last one is this is pretty tricky. To get to another nice point here, I am going over 4 and down 4. If those two numbers are the same, that is going to give you that number in the bottom of a fraction. And I need to know it flips upside down, so this would be -1/4 would be my a value. If you cannot determine it from a graph, don't worry about it. I know this whole thing is really tricky here, but you can always use the algebra that we used in the notes. But if you can look at the graph and you could argue to me like, hey, Miss Grody, I can see that the pattern is whatever, so I know the a value is 3, I would take that as an answer if you can figure it out from the graph. If you can't, use the algebra that we were using in the notes today. That'll work every time. But if you can figure it out from the graph, I'm fine with that as long as you could defend how you got your a value. Is anybody having a question? Okay, I'm going to shut up here.